Well, what we want to look at first here is a question: why do we need complex numbers? So it comes down to the situation. Well, have a look at this equation: x squared plus x plus 1. Try and solve it. Now, from all the work we've done before in 2-unit course and Extension 1 and Year 10 course, if you try and solve that one, you're going to find that you're going to not be able to solve it. There's no nice factors in it. Why not? We'll have a look. We find the discriminant. We find the discriminant is equal to -3. That means we've got no solutions. So that starts to be a bit of a problem. But really what we want to do is have the situation where we can get solutions to any quadratic equation. So we don't want to be restricted by the situation where there is no solutions to a quadratic equation. So every time we solve a quadratic, we get solutions. And that's where complex numbers come in. Because what we want to do is have a situation where we go beyond the real number field. All the courses you've done at school so far have been involving the real number field. What we want to do now is go beyond that field. We want to include other numbers. So it's a situation where we don't get a square root, where we can get the square root of a negative number. And what we get is this situation. We want to have the situation where we can have a number and square it and get -1. So what we call that is I. And the definition for this is I squared is equal to -1. Sometimes you'll see it written as the square root of -1 is equal to I. A lot of text, a lot of references don't really like this situation. But really, we're dealing with the same idea. But really what we try and talk about is the idea is I squared is equal to -1. So what it does now is it opens up what we call the complex number field. What the complex number field does is includes all the real numbers as well as taking the square root of negative numbers, which we call imaginary numbers. So we get a diagram that looks like this. So we can have our integers part of our rational field, which is part of the real field, as well as irrational numbers. So rational, irrational numbers make up what we call the real numbers. We've been limited to that in the courses so far. And now in the Extension 2 course, we go beyond that and we want to deal with the complex number system, which encompasses the real number system and the imaginary. So those two parts make up a complex number. So a complex number has two parts, the real part and the imaginary part. So that diagram sort of shows us exactly where everything fits in. So what do complex numbers look like? Well, they look like this: 3 plus 5i. There's your real part and imaginary part. So -2 plus 6i. 1 minus 3i. -2 minus I. So when we look at that, the imaginary part will have the I with it. And remember, the I is the same as the square root of -1. So we're writing it in this way: 3 plus 2i. 3 is the real part. 2i is the imaginary part. So we can write complex numbers. That complex number is z 4 plus 3i. We could write it in this terms: the real part of z would be equal to 4. The imaginary part of z is equal to 3, and that's our notation that we use. Re with the z is equal to 4. The Im with the z is equal to 3. So if we have a look here at these type of questions, z is equal to 6 minus 2i. The real part of z is 6, and the imaginary part is -2. Z is minus 7 plus I. The real part's -7, and the imaginary part is I. So we can start to see that situation, and that's how we start to describe complex numbers in terms of their real parts and in terms of their imaginary parts. So two parts to a complex number at all times.